Welcome back. In the previous video, we saw how to write the rate of appearance and disappearance equations. Now that's for individual species, right? You saw we wrote separately for each reactant and each product, right? That's the rate of appearance or disappearance with respect to a species. But if you actually decide to pursue chemistry at a more higher level, and you decide to, when you read journals and stuff on chemical kinetics, you won't see all that individual information. Instead, they provide you something else, which kind of tells all about, you want to know about the reaction. And that's called a rate law, okay? So that's what we're going to look at in this video and take it one step further with the problem. And what are the components of a rate law? As I said, let's say, keep the same reaction. A rate law is basically a succinct explanation of what is going on in the reaction. Okay? Everything you need to know about the entire reaction can be summarized in a simpler way, and that's called a rate law. And that is rate equals, typically rate law is written with respect to reactants because it's just the opposite for products. So there are some conventional, and I expect you to follow the conventional. Don't try to break the convention because I'm not teaching you that. So generally rate equals K times concentration. I'm just going to write a generic version first and then draw with respect to, I'm assuming there are two reactants, say A plus B going to C plus D. If this was the reaction, these would be my reactants and these would be my products, right? Typically, rate law is written with respect to reactants, and this is traditionally how it's done, okay? Let's explain some of the components. This is called a rate constant, okay? The value, the unit for the rate constant tells you all about the type of reaction you have at hand, okay? We'll talk more about rate constant even further as we go into it. But I want you to know the K refers to rate constant. This right here, folks, the X and the Y, okay? Together, they're called order of the species, okay? And X plus Y is called the total order of the reaction. Okay? Okay? X and Y are order with respect to each species. X plus Y gives you the total order of a reaction, right? As I said, the rate constant, the rate for the unit for rate is always molar per second, okay? This is essentially same as molarity over second. That's what it translates to, okay? The unit for rate does not change. It's constant. It's m over s. Whereas rate constant can be first order, okay? That has a separate unit. I'll get to that in just a minute, but K can be second order, K can be third order, or K can be zero order, and so on. We're going to continue that. So K can have multiple units, okay? Multiple units, whereas rate always has a single unit, okay? And reaction can be, if the reaction is first order overall, then that's what would reflect through a K. So it's easy, If you know the unit for K, you can tell whether the reaction as a whole is first order, second order, third order, etc. You cannot say that with rate alone. Even though that's the value you get, without knowing K, you can't really tell whether the reaction is first, second, third, or zero order, or fourth, fifth, sixth, seventh, whatever be the order. Whatever be the order will be the unit of K, or whatever be K's unit will tell you whether the order of the reaction. Okay? With that in mind, let's do a mathematical problem that's very, very important. So understand this. This is all I really want to say on this. So what if we say it this way, this case, okay? Rate equals, now keep in mind, these numbers are not these, okay? You cannot say this, okay? It may be that, but that you can say, okay, let me rewrite this. Let me rewrite it as N2 and H2. You cannot write it this way, okay? This is wrong. These numbers are not the exponents. The exponents are driven through actual experiment, okay? It could be 3, it could be 2, okay? We don't know that. That's why exactly I picked this particular example, because it's a human nature to just write whatever value in front of it, okay? That's usually not the case. This could be, I'm going to say could be because, you know, I don't know. Could be rate equals K times N2 power 1 H2 power 1. I'm saying it could be. Or it could be rate equals K N2 power 1 H2 power 2. Or it could simply be rate equals K H2 power 1. We don't know all this information, okay? All these are possibilities. Don't assume that this value right here, okay, is same as this value is not what the exponents are for, okay? It could be, unless the question says, say for instance, you see the word elementary reaction, okay? If you see the words elementary reaction, then I say A plus 2B going to 3C, and I ask you to write the rate law, then you can say rate equals K times A power 1, B power 2. Only under these circumstances, these numbers can become the exponent value. If you see these words, if you don't see these words, don't assume that the numbers themselves will become the exponent, because in an elementary reaction, it's already been established that these numbers are what the exponents are. So the reaction is first order with respect to A, second order with respect to B, and third order overall. Okay, that's because 2 plus 1 is 3. Okay, it's first order with respect to A, second order with respect to B, and third order overall. Okay, so don't assume that these numbers what corresponds to the actual order. And that's exactly what we're going to do in the next video, so stay tuned.